Good morning, everybody. My name is Mei Chen Lim, and today we are going to talk about carbon fiber reinforcement. The main challenge for civil engineers is to reduce the weight of their materials, increase their spans, and build higher. So this motivates civil engineers to develop materials that are lighter, thus pushing for the development of composite materials. This report consists of the overview of CFRP, which is short for carbon fiber reinforcement polymer, its definition, compositions, and production techniques, as well as the advantages and disadvantages, and lastly, its applications. Carbon fiber is made of carbon atoms that are bonded together in a chain-like pattern as seen in the figure there, and then it results in a tightly packed material, and this crystal alignment makes it resistant to breaking, as well as gives the fiber high strength and makes them perform excellently under fatigue loading. Carbon fiber reinforcement polymer, where P can sometimes mean polymer, sometimes plastic, can be used or applied in the following. We have structural strengthening in the components of buildings and bridges such as columns, beams, slabs, walls, piles, and the like, and also repairing and retrofitting of concrete, masonry, steel, and wooden structures. These can be manufactured as strips, bars, and sheets using different production techniques like filament winding, pultrusion, and hand layup processes. The first production technique is known as filament winding, and this can be likened to weaving. This involves getting a thread and then winding it over a rotating mandrel and then impregnating the fibers in a bath of resin. And this resin later will be cured in radiant heat or an oven, and then once extracted, they form a hollow product known as carbon fiber tubes that exhibit the pattern as shown there in the picture. The second CFRP production technique is known as pultrusion, which produces the reinforced fibers via a pulling method. This is the preferred form of manufacturing because pultruded products usually last longer when compared to the corrosion levels of other metals used in bridges, since pultruded products are usually resistant to weather-induced decay. The third production technique is the hand layup technique, which is the most traditional one, the oldest one, where the resin is placed first in a mold, and then a fiber fabric is placed on top of the primer, and then it is being cured and compacted to remove any excess voids, and this produces a single mat of carbon fiber. The following are the advantages of carbon fiber reinforcement polymer. First is that they have good load-bearing capacities or high load-bearing capacities. That's what makes them stiff, strong, and durable. They're also lightweight because of their high strength-to-weight ratio. That means that it is tough without getting bogged down like steel or aluminum, so it's suitable for cars and airliners also. Corrosion resistant, meaning that they can be exposed to adverse weather conditions and saltwater environments because they are resistant to oxidation. Also, they can be manufactured into multiple forms, as mentioned earlier. They have low coefficient of thermal expansion and low thermal conductivity, which means that they don't undergo much shape change or much deformation when exposed to heat. They also dampen sound. The disadvantages of CFRP are first, its high production cost. Second, its high electric conductivity despite its low thermal conductivity. That's why people usually prefer the steel ladders with better insulation compared to carbon fiber ladders that could lead to electric shock. Since it is not resistant to UV rays and wind erosion, that's why it needs a UV-resistant Pyolene sheath to cover the carbon fibers. Lastly, the applications of CFRP. It can be used in bridge construction for its high load carriage efficiency as compared to steel cables. In the table presented, it can be seen that CFRP has higher tensile strength and lower elongation at rupture as compared to using steel cables. And CFRP can be used as retrofitting for reinforced concrete in buildings, in tunnels, in piers and wharfs, and airports and railways. It's particularly useful in piers and wharfs because of its anti-corrosion properties that make it resistant to saltwater environments. Thank you for listening and have a blessed day ahead of you.